shocking incident serves as a sobering reminder of the dangers of working with live electrical systems, even at low voltages like 120 volts. One key takeaway is to always energize a circuit before performing any work, no matter how minor it may seem. Even 120 volts can cause serious injury or death if proper precautions are not taken. Wear insulated gloves, safety glasses, and appropriate clothing to protect yourself from electrical shock. Avoid working with sweaty hands, as sweaty hands can increase the conductivity of the skin, making you more susceptible to electrical shock. Be aware of your surroundings. Work in a safe position where you can easily escape if you are shocked. Never work alone. Have a coworker or supervisor nearby for assistance in case of an emergency. There are consequences of not following safety precautions. Electrical shock can cause burns, muscle spasms, cardiac arrest, and other serious injuries. Shock can cause you to lose control of your body and fall, potentially leading to additional injuries. In extreme cases, electrical shock can be fatal. It highlights the importance of taking electrical safety seriously. By adhering to safety protocols and working with caution, you can prevent electrical accidents and protect your well-being. Remember, safety first is not just a cliché, it is a crucial principle that can save lives. Let's delve into some specific safety practices to minimize the risk of electrical incidents. Firstly, always verify that the circuit is de-energized before commencing any work. Use a reliable voltage tester to confirm the absence of voltage on all conductors. Don't rely solely on the circuit breaker position, as breakers can fail or be mislabeled. Secondly, implement a lockout/tagout procedure. This involves physically locking the circuit breaker in the off position and attaching a tag indicating that the circuit is being worked on. This prevents accidental re-energization of the circuit by someone unaware of the work being performed. Thirdly, personal protective equipment is paramount. Always wear appropriate PPE, including insulated gloves, safety glasses, and arc-rated clothing when working on or near electrical equipment. Insulated gloves protect your hands from electrical shock. Safety glasses protect your eyes from arc flash and debris, and arc-rated clothing provides a barrier against burns from arc flash. Fourthly, maintain a safe working distance. Keep a safe distance from exposed energized parts. Use insulated tools with appropriate voltage ratings to avoid direct contact with live conductors. Fifthly, be mindful of environmental conditions. Avoid working in wet or damp environments, as water significantly increases the risk of electrical shock. If it is unavoidable, take extra precautions such as using ground fault circuit interrupters or GFCIs and wearing rubber boots. Sixthly, regularly inspect your tools and equipment. Ensure that all tools and equipment are in good working order, with no frayed cords, cracked insulation, or other defects. Damaged tools can create hazardous conditions and increase the risk of electrical shock. Seventhly, provide adequate training. Ensure that all personnel working on or near electrical equipment have received adequate training in electrical safety practices. Training should cover topics such as hazard recognition, lockout/tagout procedures, proper use of PPE, and emergency response. Eighthly, develop and follow safe work procedures. Establish written safe work procedures for all electrical tasks. These procedures should outline the steps to be taken to minimize the risk of electrical accidents. Ninthly, conduct regular safety audits. Periodically conduct safety audits to identify potential hazards and ensure that safe work practices are being followed. These audits should be conducted by qualified personnel and should include a review of work procedures, equipment maintenance, and training programs. Tenthly, promote a culture of safety. Foster a workplace culture that prioritizes safety above all else. Encourage employees to report hazards, ask questions, and take responsibility for their own safety and the safety of others. Some additional considerations involve the human element and situational awareness. Firstly, avoid distractions and multitasking. Electrical work requires focus and concentration. Avoid distractions such as cell phones or conversations that can divert your attention from the task at hand. Secondly, be aware of your physical condition. Fatigue, stress, and illness can impair your judgment and increase the risk of errors. If you are not feeling well, avoid working on electrical equipment. Thirdly, communicate effectively. Communicate with your coworkers about the work you are doing and any potential hazards. Ensure that everyone is aware of the safety precautions that are in place. Fourthly, stop and reassess if unsure. If you are ever unsure about how to perform a task safely, stop and reassess the situation. Do not proceed until you have a clear understanding of the procedures and potential hazards. Fifthly, learn from incidents. Investigate all electrical incidents, even minor ones, to identify the root causes and prevent future occurrences. Share the lessons learned with your coworkers. A deeper dive into grounding and bonding is crucial. Firstly, understand the purpose of grounding. Grounding provides a low impedance path for fault current to flow back to the source, allowing the circuit breaker to trip and energize the circuit. Secondly, ensure proper grounding connections. Make sure that all grounding connections are clean, tight, and corrosion-free. Poor grounding connections can impede the flow of fault current and increase the risk of electrical shock. Thirdly, bond non-current carrying metal parts. Bond all non-current carrying metal parts of electrical equipment together to create an equipotential plane. This minimizes the voltage difference between metal parts and reduces the risk of electrical shock. Fourthly, use ground fault circuit interrupters or GFCIs. GFCIs are designed to detect small amounts of current leakage to ground and quickly interrupt the circuit. They are required in wet locations and other areas where there is a high risk of electrical shock. Fifthly, regularly test GFCIs. Test GFCIs monthly to ensure that they are functioning properly. Press the test button on the GFCI and verify that the circuit is de-energized. Arc flash hazards also warrant careful attention. Firstly, understand arc flash. Arc flash is a dangerous phenomenon that occurs when a short circuit creates an electric arc, releasing a tremendous amount of energy in the form of heat, light, and pressure. Secondly, conduct an arc flash hazard analysis. Perform an arc flash hazard analysis to determine the potential arc flash incident energy levels at different locations in your electrical system. Thirdly, label equipment with arc flash warnings. Label electrical equipment with arc flash warnings indicating the potential incident energy levels and the required personal protective equipment. Fourthly, wear appropriate arc-rated PPE. Wear appropriate arc-rated PPE, including arc flash suits, face shields, and gloves when working on or near energized electrical equipment. Fifthly, reduce arc flash hazards. Implement measures to reduce arc flash hazards, such as using remote racking devices, current limiting fuses, and arc flash relays. Specific code requirements must be met. Firstly, comply with the National Electrical Code or NEC. The NEC is a comprehensive set of standards for electrical installations. Ensure that all electrical work complies with the latest edition of the NEC. Secondly, follow local codes and regulations. In addition to the NEC, comply with all local codes and regulations governing electrical work. Thirdly, obtain permits and inspections. Obtain the necessary permits and inspections for all electrical work. This ensures that the work is performed safely and in accordance with applicable codes. Fourthly, use listed or labeled equipment. Use only electrical equipment that is listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. Fifthly, maintain accurate documentation. Maintain accurate documentation of all electrical work, including drawings, specifications, and test reports. This documentation is essential for troubleshooting and maintenance. Emergency response procedures are critical in the event of an electrical incident. Firstly, know the emergency procedures. Familiarize yourself with the emergency procedures for electrical incidents, including how to shut off power, provide first aid, and call for help. Secondly, keep emergency contact information readily available. Keep emergency contact information, such as the phone numbers for emergency services and qualified medical personnel, readily available. Thirdly, provide first aid. If someone is shocked, immediately shut off the power and provide first aid. Call for emergency medical assistance if necessary. Fourthly, report all incidents. Report all electrical incidents to your supervisor and to the appropriate authorities. This allows for a thorough investigation of the incident and the implementation of corrective actions. Continuous improvement is key to maintaining a safe electrical work environment. Firstly, stay up to date on safety information. Stay up to date on the latest electrical safety information and best practices. Attend training courses, read industry publications, and participate in online forums. Secondly, share safety information with others. Share your knowledge of electrical safety with your coworkers. Encourage them to ask questions and to report any potential hazards. Thirdly, participate in safety committees. Participate in safety committees or other safety-related activities. This provides an opportunity to contribute to the development and implementation of safety programs. Fourthly, continuously evaluate and improve safety programs. Continuously evaluate and improve safety programs to ensure that they are effective and up to date. Seek feedback from employees and incorporate their suggestions into the programs. Some additional notes to remember are: firstly, the importance of proper planning. Before starting any electrical work, take the time to plan the job thoroughly. Identify potential hazards, develop a safe work plan, and gather the necessary tools and equipment. Secondly, the value of a second opinion. If you are ever unsure about how to perform a task safely, ask for a second opinion from a qualified colleague or supervisor. It is always better to be cautious than to take unnecessary risks. Thirdly, the power of communication. Communicate effectively with your coworkers throughout the job. Keep them informed of your progress, potential hazards, and any changes to the work plan. Fourthly, the need for continuous learning. Electrical technology is constantly evolving. Make a commitment to continuous learning to stay up to date on the latest advancements in safety practices. Fifthly, the responsibility we all share. Electrical safety is everyone's responsibility. By working together and following safe work practices, we can create a safer work environment for ourselves and for others. Let's consider specific examples of situations where these principles apply. Firstly, replacing a light fixture. Before replacing a light fixture, always de-energize the circuit at the breaker panel. Verify that the circuit is de-energized using a voltage tester. Wear insulated gloves and safety glasses. Carefully disconnect the old fixture and connect the new fixture, ensuring that all connections are secure. Secondly, working in a panel. When working inside an electrical panel, always wear appropriate ARC-rated PPE. Use insulated tools with appropriate voltage ratings. Keep a safe distance from exposed energized parts. Never work alone. Thirdly, troubleshooting a circuit. When troubleshooting a circuit, always energize the circuit whenever possible. If it is necessary to work on an energized circuit, use extreme caution and wear appropriate PPE. Use a voltage tester to identify energized conductors. Fourthly, installing a new outlet. When installing a new outlet, always de-energize the circuit at the breaker panel. Verify that the circuit is de-energized using a voltage tester. Use a properly grounded outlet and ensure that all connections are secure. Fifthly, running new wiring. When running new wiring, always follow the National Electrical Code or NEC and local codes. Use the correct size and type of wire for the application. Properly support and protect the wiring. In addition, consider the impact of new technologies on electrical safety. Firstly, renewable energy systems. Renewable energy systems, such as solar and wind power, present unique electrical safety challenges. Ensure that these systems are installed and maintained by qualified personnel and that they comply with all applicable codes and standards. Secondly, electric vehicles. Electric vehicles also pose new electrical safety risks. Be aware of the potential hazards associated with high-voltage batteries and charging systems. Follow the manufacturer's instructions for safe operation and maintenance. Thirdly, smart grid technologies. Smart grid technologies, such as smart meters and advanced distribution automation systems, can improve the efficiency and reliability of the electrical grid. However, they also introduce new cybersecurity risks. Implement appropriate security measures to protect these systems from cyber attacks. Fourthly, energy storage systems. Energy storage systems, such as batteries and flywheels, are becoming increasingly common. These systems store large amounts of energy and can pose significant electrical safety hazards. Ensure that these systems are installed and maintained by qualified personnel and that they comply with all applicable codes and standards. In summary, electrical safety is a critical concern for anyone working with or around electrical equipment. By following the principles and practices outlined here, we can significantly reduce the risk of electrical accidents and create a safer work environment for ourselves and for others. Remember, safety is not just a slogan, it is a way of life. Let us all commit to making electrical safety a top priority in everything we do. It is important to remember some further points, which are firstly, the legal and ethical considerations. There are legal and ethical obligations to ensure a safe working environment. Ignoring safety can lead to legal repercussions and, more importantly, can cause harm to individuals. Secondly, the role of management. Management plays a crucial role in promoting a safe work environment. They should provide adequate resources, training, and support to ensure that employees can work safely. Thirdly, the importance of reporting near misses. Reporting near misses is crucial for identifying potential hazards and preventing accidents. Encourage employees to report near misses without fear of reprisal. Fourthly, the need for regular safety meetings. Regular safety meetings can help to keep employees informed about safety issues and to reinforce safe work practices. Fifthly, the value of a safety checklist. Using a safety checklist can help to ensure that all necessary safety precautions are taken before starting a job. Sixthly, the importance of a good attitude. A positive attitude towards safety is essential for creating a safe work environment. Encourage employees to take safety seriously and to look out for one another. Seventhly, the need for continuous vigilance. Electrical hazards can be present at any time. It is important to remain vigilant and to be aware of your surroundings at all times. Eighthly, the value of experience. While experience is valuable, it is important not to become complacent. Always follow safe work practices, regardless of how much experience you have. Ninthly, the importance of respect. Respect electricity and the potential hazards it poses. Never take electricity for granted. Tenthly, the need for a safety culture. Creating a strong safety culture is essential for preventing electrical accidents. A safety culture is one in which safety is valued and prioritized by everyone in the organization. Lastly, do not let overconfidence put you or others at risk of a potentially fatal outcome.